PU2 aspirants, so I hope all of you are preparing really well for your final exams. And yes, we know that solving model papers are very critical for having an understanding of the level of preparation we have, right? And PU board has itself released 3 model papers for all the subjects. So it is my suggestion, recommendation and request to please solve at least 2 model test papers before going to the exam, so that you can have an understanding of how to manage time, what level of questions being asked, how to answer them, so you will have an idea. So in this video I am going to give you the detailed solution of PU2 model paper 1. Okay, so I'll be discussing all the questions that have been asked in this in detail. So let us see. So you know, here the first 15 questions will be your MCQ questions. Next 16 to 20 will be your 5-marker questions. Then 21 to 25 will be your 2-marker questions. There will be total 5 questions in which you have to attempt any 3. Now similarly 26 to 34 will be your 3-marker questions, including both inorganic and organic. So here we have 2 sections, right? So sorry, one second. So this was your question. Here you have 2 sections. One is for your 3 markers of inorganic chemistry, then you have 3 markers of physical chemistry, right? So here you have to attempt 3 out of 5 and here you have to attempt 2 out of 4. Okay, then you have long answer questions. 6 questions are there where you have to attempt 4 questions. Okay, so just let me write down here. This is 3 out of 5 and here total you will have 5 plus 4, 9 questions, and you have to attempt 3 plus 2, 5 out of 9 questions, 4 out of 6 questions, 3 out of 6 numerical questions. Okay, so now moving to the first section, that is 1-marker question. The role of CO2 in a Coles reaction is, so if you remember Coles reaction, I'll just draw this. We have O minus, Na plus, and it reacts with carbon dioxide, right? So this group, okay, attacks on this one. So C is an electrophile, so it acts as a weak electrophile. Next question we have here. In DNA, the linkage between the different nitrogenous bases. So the nitrogenous bases forms here hydrogen bonds. Okay, so correct answer is option number D. So this was also easy question. The complex PtCl2 4NH3Br2 is treated with excess of AgNO3. 2 mole of AgBr is precipitated. If 2 mole of AgBr is precipitating, that means what? 2 Br will be outside, right? So we have like this: PtCl2 NH3 4Br2. Okay, the primary and the secondary valence of this complex is, so if you see here, platinum has total, we have secondary valency will be 6, right? So you have to see secondary, primary and secondary valency. Secondary valency is the coordination number, so coordination number is 6, so we can eliminate these 2 options. Next, coming to the charge of the platinum, that is your primary valency. So this is x minus 2 plus 0 minus 2 is equal to 0. X is equal to plus 4. So we have 4 and 6, option number C here. Okay. Next, enantiomers are non-superimposable mirror images on each other. Okay, then a racemic mixture shows 0 optical rotation. Both the statements are correct here, right? So option number A is the correct answer. So these all are, I will be leveling them also. I can say this was a easy question. Okay, the most stable manganese compound, this one I can say it is a difficult question because you need to read the NCERT book line by line to undergo this one. So first of all, we know that oxides are very stable, so we can eliminate this one and this one. Now coming to Mn2O7 and MnO2, so this is a larger compound, this is a smaller compound, so definitely MnO2 is more stable. Okay, this was a difficult question. Next, among the following alkyl benzenes, which one will not give the benzoic acid on oxidation with acidic KMnO4 solution? So here we have primary, okay, here we have secondary, here also primary, but this is tertiary, this won't react. Here we will get an alkene group, so correct answer is option number B here. Next, this one I can say as a moderate level question. An ambidentate ligand, this is a very easy question. You know Cn minus is an ambidentate ligand. Next, E naught value of Fe2 plus, Zn2 plus and Sn2 plus are given respectively. So let me just write down. Fe2 plus is having how much? 0.44 okay. Then you have Zn2 plus, okay, and that is your minus 0.76, okay. Then we have what is it, Sn2 plus, okay, and this is minus 0.14 volt. Now you see that we want to protect iron, right? So that means what? The other metals which is covering the iron should have more oxidation or should have more tendency to get oxidized, right? So if it has more tendency to get oxidized, means its reduction potential should be lower than that of Fe, right? So you see, this is the reduction potential. If it has least reduction potential, that means it has highest oxidation potential. So if I just order them in the order of oxidation potential, then it will be zinc, okay, then we have Fe, then we have tin, right? So that means zinc, if it is coated, if Fe is coated with zinc, then zinc will undergo oxidation faster, okay. So that is why the correct answer here will be zinc only, option number B, okay. Next, moving to question number 9, the chemical name of phosgene is, so this is a direct easy question, answer will be carbonyl chloride, option number D. Coming to question number 10 here, in a solution containing non-volatile solute, the mole fraction of solvent is 0.9. The relative lowering of vapor pressure is. This is also very easy question, okay. So you know what is relative lowering vapor pressure, delta P by P naught is equal to mole fraction of the solute, right? Now here the question is given mole fraction of the solvent is 0.9. That means what is the mole fraction of the solute? You know mole fraction of solute plus solvent is 1. So if it is 0.9, this is 0.1. So this value will be 0.1. So relative lowering vapor pressure will be 0.1. Next, all natural and artificial radioactive decay of unstable nuclei takes place by. Easy question again. You know this is a first order kinetics, okay. Next, match the following. Yeah, this question can be little I can say confusing if you haven't studied the hormones properly. So glucocorticoids is responsible for carbohydrate mechanism, so A will be 3, so we can eliminate option number A and C, okay. Next, mineral corticoids, it is used for the excretion and kidney, so B has to be 5. So we have B5 only one option, so option number B is the correct answer, okay. You can eliminate this one as well. Then you can see testosterone is for the male sex hormone, right? Yes, responsible for development of secondary characters in male, so C has to be 4. Estradiol is for your development of secondary female characters, so that is your option number 1 second. Yes, so that is D has to be 1, okay. Next, para-aminobenzene is prepared from benzene disonium chloride and aniline in. So it is a slightly acidic medium, option number A. So this is also easy question. Next, I have the chemicals used to convert commercial alcohols into denatured alcohol is your copper sulfate and pyridine, option number C. So I can say this one a difficult question if you haven't studied properly line by line the NCERT questions. NCERT book. Next, during osmosis the solvent molecules are moving from, this is easy question, direct definition based question, from hypotonic solution to hypertonic solution, option number A, right? Here there is more like solvent, so from solvent to solute, okay. Next, coming to fill in the blanks, the melting point of interstitial compounds is greater, okay, so it has to be greater. Next, benzene disonium chloride fluoroborate on heating decomposes to give you fluorobenzene, okay. Okay. The simplest hydroxy derivative of benzene is nothing but your phenol. This is very simple question, we know. When a non-volatile solute is added to the pure solvent, the freezing point of the solution decreases, right? Depression in freezing point and elevation in boiling point. Ozonolysis of alkenes followed by reaction with zinc dust and water gives you what? So that gives you aldehydes. It can also give you ketones, but according to the options we have to go for this one, okay. Now we will move to 2 marker questions. Now see, 2 marker questions will be asked from these chapters. It has to be haloalkanes and haloarenes, alcohols, biomolecules, and then you will get 1 question from either from solutions or from chemical kinetics, 1 question either from DNF block or from coordination compounds. This I have done after analyzing all the 3 blueprint papers. So from electrochemistry you won't be getting any 2 marker question. Okay. Now moving to here, Schwartz reaction with an example. This is direct question, easily you can score 2 marks here. So there will be 5 questions, you have to attempt any 3. So this question has to be a must one. So you have to write the reaction and the example. So what is Schwartz reaction? Whenever we want to produce metal fluoroalkanes, we react haloalkanes in presence of metallic fluorides. Okay, so you have to write the statements. Alkaline fluorides are synthesized by heating an alkyl chloride or bromide in the presence of metallic fluorides, such as any 2 examples you can give here. Clear? So this one easily 1 mark here, 1 mark here, you will get 2 marks. Next question, write the reactions that shows that glucose has 5 hydroxyl groups and 1 aldehyde group. This is also easy and direct question from biomolecules chapter. So for 5 hydroxyl groups, you have to react it with acidic anhydride to get you pentaacetate group, right? So glucose on acetylation with acetic anhydride gives glucose pentaacetate, which confirms the presence of 5 OH group in the glucose. Okay, so you have to write the reactions as well. Okay, you have to write the reaction. So glucose is there, acidic anhydride is there, you will get pentaacetate group here. Next one, presence of an aldehyde group. So if you react this compound with bromine water, okay, we get gluconic acid, which tells that there is a aldehyde group present. Okay, glucose on mild oxidation with Br2 gives gluconic acid. This indicates the carbonyl group present in the glucose is an aldehyde group. Okay, clear? Fine. Next question number 23, define half-life period of a reaction. Write the relationship between the half-life period and the initial concentration of 0th order reaction. This is also direct and easy question. So what is half-life? The time required for during which the concentration of a reactant is reduced to half of its initial concentration is called as the half-life period of a reaction. Now if I want to calculate what is the relationship for 0th order, T half is equal to A naught by 2K, okay, where A naught is initial concentration, K is the rate constant. So you have to write this and this. Also mention the terms. Here it is initial concentration and here it is rate constant. Clear? Okay. Next we have write the reactions involved in the preparation of phenol from cumene. Okay, direct question. This one also I'll say this is also easy question. So any 3 you have to write. So all the questions are damn easy and direct. So cumene is oxidized in the presence of air to give you cumene hyperperoxide. It is converted to phenol and acetone by treating with dilute acid. Very simple language it is written. So cumene is treated with what? Oxygen to give you cumene hyperperoxide. Then it is treated with H plus and H2 to give you phenol plus acetone. Clear? Okay, last question of 2 markers. Iron catalysts are the iron catalyzes the reaction between iodide and persulfate ions in the reaction. 2I minus gives S2O8, 2 minus gives you I2 plus 2SO4, 2 minus. Explain the catalytic action of catalyst iron by using the chemical reactions. I can say that this question is definitely a difficult question because if you haven't read the reactions that is given in the book, this part from DNF block, this is from the chapter DNF block. If you study the catalytic activity or the catalytic property of the transition elements, there a reaction is given. So that is the answer for this question. I'll be showing you. So yes, so catalytic iron activity of iron is given by, so what happens? Fe3 plus first oxidizes I minus to I2. Okay, now what happens? This Fe2 plus, then again, so Fe3 plus is reduced to Fe2 plus, I minus is oxidized to I2. Now this Fe2 plus reacts with S2O8 2 minus to again give you Fe3 plus and SO4 2 minus. Now if I add these 2 reactions, this one will be the final reaction that is produced. Okay, so this question was definitely a difficult question, but out of 5 you have to attempt any 3, so you can leave this question. Okay, but yes, for the final exam, do prepare this question. Next, coming to 3-marker questions. So here we have 2 sections. First 3-marker questions will be from inorganic chemistry. In inorganic chemistry, 2 chapters are there, your DNF block and coordination. So out there will be total 5 questions, out of which you have to attempt any 3. In that 5 questions, there will be, like, it can be either 2 plus 3 or 3 plus 2. Okay, so that is what is there. And in the second part, you have 3-marker questions. There will be 4 3-marker questions from physical chemistry, and you have to attempt any 2. In there, 1 will be solutions, 2 will be electrochemistry, and 1 will be chemical kinetics. Okay, so let us see them. First question, study of actinoids is very difficult, give any 3 reasons. So this one is also very easy question from the chapter D and F block. So you know the reasons. They are obtained in nanograms, they are very rare, and they have a shorter half-life period. Okay, very short half-life time to do or to analyze them. So that is the 3 reactions, 3 reasons, 3 marks you will get. Next, so this one is from coordination. Okay, from the complex mercury tetrathiocyanato S cobaltate, what is the coordination number of cobalt? Identify the ligand present. Does ionization isomerism exist or not? Okay, so this is very simple question. First of all, let's draw the structure. So mercury is there, okay, and then you have tetrathiocyanato S cobalt. So you can write like this, COSCN4. Okay, now cobalt is +3, okay, and SCN is -4. So 3 minus 4, it is -1, and this is already +1. So -1 + 1 will get cancelled, and we will get this as the final product. Now what is the coordination number of cobalt? So it is 4, right? SCN 4 is there. So here coordination number will be 4. Now identify the ligand. So it is SCN minus. So ligand is SCN minus. Ionization isomerism exists? No. So ionization isomerism will exist if there is some counter ion present. Okay, but here we cannot exchange the metal. We can exchange the ligands, but there is no other ligand. So that is why it is no. Okay. Yes, so we got third question is there. Okay, a student of 2nd PU performs 2 trails of reactions between Ki and KMnO4. In first trail, student adds small amount of acid to the reaction mixture, and in the second trail, student forget to add acid to the reaction mixture. Then student observed that different color was obtained in the first and the second trail. Give reason for the above observation. Write the possible chemical reactions to both the trails. Okay, so first you have to give reason, that carries 1 mark. The writing 2 reactions for 2 experiments, that gives you 2 marks, so total 3 marks. So first let us see why the colors are different. Okay, so first if I want to write, you can write KMnO4. Okay, KMnO4 reduces to Mn2 plus in acidic medium, okay, and MnO2 in neutral or alkaline medium. Okay, that is why we observe different colors. That is why we observe different colors. Okay, that is the first part of the question. Now you have to write the reactions for both the case. Okay, first, so if I write for acidic medium, okay, so I have KMnO4 minus plus I minus, okay, that's get converted to Mn2 plus, okay, and I minus gets converted to I2. Okay, now here it is +7 state, +7 to +5, it is 5 electrons are there. Okay, this is reduction. Now if to balance, I will make 2 I minus and I2. Okay, so how many electrons are used here? If you see, 2 electrons are used. Okay, and this is oxidation. Now what I'll do to balance the number of electrons, I'll multiply this equation with 2 and this equation with 5. So I'll get 2MnO4 minus and 2Mn2 plus. Okay, this equation I have to multiply it with 5. So you see, 5 into 2, this one will become 10, right? And here I have to multiply 5, this will become 5. Next thing, we'll go for balancing of oxygen. So here you see there is 4 oxygen, right? To balance that, I will add here 4 oxygen, means I have to add how much? 4 water. So that gives me 8H plus, right? So this side I have to add 8H plus. 1 second, just let me take, yes. So now finally what reaction I am getting? So just if I write the final reaction, I will get 2MnO4 minus, okay, plus 10I minus plus 8H plus gives me 10I minus, I have written, then 2Mn2 plus 5I2 plus 4 water. Okay, so let's just see if everything is balanced here or not. 2Mn, is it balanced? Manganese atoms are balanced. Then I have 8 oxygen, okay, 1 second. Oxygen, okay, so here I did a mistake, yes. So it was 8 oxygen, right? So I have to add 8 water. Then I have to add here 16H plus, right? So this has to be 16H plus. So here also I will change. Okay, 1 second. This has to be 16, this has to be 8. So let me see here. So 2Mn, 8 oxygen, 10I, 16H, 16H. Total charge here is plus 4, and here if I see, this is minus 2, this is minus 10, and this is plus 16. So 16 minus 12 is plus 4. Yes, charge is also balanced. Okay, so this reaction is balanced for your I'll say acidic medium, right? Now if I go for basic medium, so we will have this one. So now let's see how the reaction happens in the basic medium. Okay, so if I take now basic medium, okay, so here what happens, MnO4 minus is there, okay, and it reacts with I minus to give here MnO2 plus IO3 minus. Now if I check this, this is plus 7 definitely, and here if you see, it is plus 4. So here what happens, it is 3 electrons, right? Now here it is I minus, and here if I see X minus 6 minus 1, so this is plus 5, right? So I have here 6 electrons, okay? So this is oxidation and this is reduction. Now to balance it, I can multiply this one with 2. So I will get 2MnO4 minus and 2MnO2. Now let's see the number of oxygen here. Here we have 8 oxygen and here we have 7 oxygen. To balance it, I will add one more water. Okay. Now if you see here, I have 2H plus, so I will add 2H plus on this side. Now it has to be in the basic or neutral medium, so I will add 2OH minus as well, and here also I will add 2OH minus, right? Now you remember here 2H plus and 2OH minus will make two water molecule, and this side I have one water molecule, so I can cancel this one, okay, and I will get here one water molecule. Okay, so this will be my final equation. So you can check here, I will write it once again. H2O plus 2MnO4 minus plus I minus gives 2MnO2 plus IO3 minus plus 2OH minus. Okay. Now if I see balancing, you have 2 manganese, you have 4 2s are 8, 9 oxygen, and here we have 2 2s are 4 plus 3 7, 8, 9 oxygen. We have 2 hydrogens and 2 hydrogen and 1 iodine and 1 iodine. Okay, so that is what is there, the balanced equation in the basic medium. So if you write the first one, why there is difference, this carries 1 mark, this reaction carries 1 mark, and then this reaction carries 1 mark. So I have already shown you how to balance, so you do not have to mug up the balancing of equation. You can directly do it in the examination hall. Now moving to next question number 29. So define crystal field splitting and sketch the energy level diagram for the crystal field splitting of d orbital in a tetrahedral complex. Now here what is crystal field splitting? So we know all that the d orbitals are degenerate, but when the ligands approach, the degenerate d orbitals split, right? So that is what we have to write in this one. So the splitting of degenerate d orbitals due to the presence of the ligand in a definite geometry is termed as crystal field splitting. Okay, so I consider that this part definition you might not be knowing the exact definition, but yes, this diagram will be known to everyone. So it is like 1 carries this definition and 2 mark carries for the diagram. So easily, so I will mark this as a moderate question because this definition is not very direct. So diagram you can see in the book it is given, so you have to mention degenerate d orbitals here. Then you have a slight increase in the spherical field. Then when the ligands approach in the tetrahedral split, there is a splitting here. This is E, this is T2 and this is 2/5, this is 3/5. You have to mention it carefully. Okay, so all the leveling should be done perfectly to get full marks in this question. Next, moving to question number 30, what is the significance of synergic effect in metal carbonyls? How many bridged and non-bridged CO ligands are present in octacarbonyl dicobalt complex compound? Okay, so this is also a very important question. So how does synergic effect takes place in metal carbonyl? So what is its significance? So here what happens, I have given the metal carbon bond in the metal carbonyls possess both S and P character. So how the sigma bond is formed? The sigma bond is formed by the donation of lone pairs of electrons on the carbonyl carbon into a vacant orbital of the metal. Okay, so from the filled orbitals of carbon to the vacant d orbital of metal. Next we have the MC pi bond is formed by the donation of a pair of electrons from a filled d orbital of metal into the vacant antibonding pi star orbital of carbon monoxide. Now this is what metal carbonyls look, but the question here is actually asking about the significance. So you can write here in significance, this makes the bond more strong. Okay, makes the bond, which bond? CO bond stronger. Okay, sorry, not CO bond, makes the metal carbon bond more stronger. That is actually the significance. Now if you know the next part, the carbonyl carbon, you have to know the structure of this one. Sorry, one second. Yes, so next you have to know the structure of this one. So what is the structure? Octacarbonyl dicobalt 0 complex compound. So the structure is like this for this one. CO, you have C double bond O, C double bond O, and here we have carbonyl. Okay, and here also we have carbonyl compounds. Okay, so how many bridged carbonyl compounds we have? So bridged we have bridge we have 2 and non-bridge. Okay, non-bridge we have 6. Okay, so total 8 carbonyls are present in this way. So this structure is very important. So this I can say as a difficult question because both the parts of the questions are little on the difficult side. Okay. Now we will move towards the 3 marker questions in physical chemistry. So here you will be having 4 questions and you have to answer any 2. The first question is definitely a difficult question, which is not a very easy question. Direct measurement of conductivity of ionic solutions by Wheatstone bridge is not possible. Give reasons, suggest a remedy to resolve it. So you have to give at least 2 reasons and 1 remedy to give you 3 marks. Okay, so I will be telling you the answer for this one. The first thing here is, the first problem is direct current will change the composition of the ionic mixture due to the electrolysis. So we cannot use direct current there. And the second one is solutions cannot be connected to the bridge like another solid conductor. Okay, it is a liquid. How can you connect it with the wire? So these are the 2 problems that we have. What are the 2 solutions for that? Instead of direct current, you can use AC current, that is your alternating current. And for this one, electrolytic solutions is connected to Wheatstone bridge by using conductivity cell. So we have a conductivity cell in which we pour the electrolyte, and now this conductivity cell is connected to the Wheatstone bridge. So here you have to write 2 reasons, and any one of them if you write, you will get 3 marks. Okay, so this was definitely a difficult question. Next question is from the chemical kinetics. For the reaction R to P, the potential energy diagram is given below. By observing the above diagram, answer the following questions. What is the value of the activation energy of the reaction? Okay, so if you see, activation energy is how much? See, this is the activation energy. Now you can see this is total here is 20 and this is total is 60, right? So I can subtract 60 minus 20, that is your 40. So the activation energy is 40 kilojoule. Okay, next we have what is the value of delta H of the reaction. So delta H is what? Energy of the products minus energy of the reactants, right? So this is the energy of the products and this is the energy of the reactant. So this subtracted 20 minus 5 or 5 minus 20, that is your minus 15 kilojoule per mole. Okay, next question, draw the potential energy diagram for the reaction P to R. So you have to do the diagram for P to R. So let us draw that. Okay, yes, so I will have the same thing. Okay, we have this one and this is product energy is 5. Okay, so now you see, from R to P, if it was exothermic, P to R it will be endothermic. So I have P here. Okay, I'll draw like this. Okay, so P energy was 5, okay, R energy is 20, okay, so this is R where I have 20, okay. Now what is the activation energy that I have to give here? The threshold energy is obviously 60, okay. So this is P, this is R, and the energy that I have to provide here, okay, this is my, yeah, this is my activation energy. So not this one, 1 second, yeah, so the activation energy is this one, okay. So I have to provide almost 55 kilojoules for the activation energy reactions to take place, okay. So this one is the diagram for the reaction from P to R, okay, clear. So P to R means from 5 joules to 20 joules, okay. So this is an endothermic process. So that is why if you see, the reaction value will be plus 15 kilojoule here, okay. That is the diagram. Next, moving, so this question also I can say moderate, not very easy, okay. This is little bit moderate type question. Next, we'll go to state Faraday's second law and mention any 2 factors on which the products of electrolysis depends. This one also will be considered as a moderate question because you might be knowing this one, but this part can create little bit confusion among the students. So please mark this important question. So Faraday's second law, very direct question. So here it is like 1 mark is for the statement and 2 marks is for the factors writing. So it states that when the same amount of electricity is passed through the different electrolytes, the solutions, the masses of the substances deposited or liberated at the electrodes is directly proportional to their equivalent weight. So that much, if you write just the statement, that will give you 1 mark. Next, what happens? 2 factors. So I have given you 5 factors. You can write any 2 of them. Nature of the electrolyte, type of the electrode used, standard electrode potential, concentration of the electrolyte over voltage. Okay, so these are the 5 factors on which the products of the electrolysis will depend. Okay. Next, we will move to name any 2 components present in the binary solution. Which component determines the physical state of the binary solution? So this was very easy question. I can say you can just write 2 components as solute and solvent, and the physical state of the solution depends on the phase of the solvent. If solvent is gas, then it is called gaseous solution. If solvent is solid, then it is called solid solution. If solvent is liquid, it is called liquid solution. Okay, so here 1 plus 1 plus 1, 3 marks you will get. Very easy question. Okay, now we will move to 5 marker questions. The 5 marker questions will be from organic chemistry. So there will be total 6 questions, out of which you have to attempt any 4, and 5 chapters are there. So 5 chapters, 5 questions, and aldehydes, ketones will have 1 more extra question. Okay, so let's see the first question here from the chapter. How do you distinguish between primary, secondary and tertiary amines by using Hinsberg reagent with chemical equations involved? Give the preparation of para-hydroxyazobenzene. Okay, so first of all, this one, if you write for this three all primary, secondary and tertiary, you will get 3 marks here. And this one, the preparation of para-hydroxybenzene, will give you 2 marks. So this question is from the amines chapter. and I can say this is an easy question. Okay, so let's see the answer here. I'll first discuss the B part because of the space. Next slide we'll go for the first part. So when the benzene diazonium chloride reacts with phenol in a slightly acidic medium, it produces para-hydroxy azobenzene. This carries 1 mark, and then when you write the reaction where you have taken benzene diazonium chloride and phenol and in this in slightly acidic medium, okay, so this one second, okay, sorry, this one is actually in the slightly basic medium, right? So here I will get OH, so this gives you OH minus. In that medium if you react, you will get para-hydroxy azobenzene. If you create para amino azobenzene, then we use the medium there, acidic medium, right? So yes, this has to be clear, be very clear in this one. So this is basic medium, it will give you this particular compound. Okay, so now coming to the first part, how will you distinguish between primary, secondary and tertiary? So we use the reagent benzene sulfonyl chloride, also known as Hinsberg reagent. So primary amines will react to form N-alkyne benzene sulfonamide, which is soluble in alkali, okay, due to the presence of acidic medium. So you have to write this is a soluble in alkali. Next, secondary amines react with Hinsberg reagent to form N-dialkyl benzene sulfonamide, which is insoluble in alkali due to the absence of acidic hydrogen on nitrogen. And tertiary amines will not react at all. Okay, so this was a lengthy question, but yes, very easy question. Next, going to question number 36, between methanol and ethanol, which would undergo aldol condensation, and write the chemical reaction involved in it. Okay, although phenoxide has more number of resonating structures than carboxylate ion, carboxylic acid is a stronger acid than phenol. Give reason or why. So here this also carries, like you can say this will carry 3 marks and this will carry 2 marks. 3 marks how? You have to first mention that between methanol and ethanol which one will undergo aldol condensation, and then if you write the product correctly you will get 3 marks here, and here you have to mention the reason. So basically this one we can know that here ethanol will have aldol condensation because it has alpha hydrogen. Now to write the product here, so if you remember I can tell you how the reaction happens. So I have ethanol, okay, in presence of OH minus, what will I get first? We will get a nucleophile produced, right? Yes. Now this one will react on this one, okay, so this negative charge will attack on this one. So what I'll get, this one will go here, so I'll get here CH3 COH H I have, and then this part is attached, right? So CH2 COH. Okay, now what will happen? There will be dehydration, okay, then OH and H will be removed, and here I will get CH3 CH double bond CH COH. Okay, so if you write this complete reaction you will get 2 marks, here 1 mark, so total 3 marks. Now coming to the second part of the question, that carboxylic acid is a stronger acid, so definitely that is because of the carboxylate ions has equivalent resonating structures, whereas phenoxide ions does not have equivalent resonating structures. That is the first point. Second point is, in phenoxide ion if you do the resonance, the negative charge comes on the carbon, which is not a electronegative atom, but in a carboxylate ion during resonance the negative charge comes under more electronegative atom, that is oxygen. Okay, so the negative charge is on the less electronegative atom carbon in phenoxide ions, whereas in carboxylic or in carboxylate ion it is on the more negative, more electronegative atom, that is oxygen. Okay, so 2 reasons will give you 2 marks here. So I can say this question was a bit moderate level question, okay, from the chapter alcohols, phenols and ethers. Next, complete the following equation and explain the Seitzef rule with an example. Okay, so this is from the chapter haloalkanes and haloarenes. Okay, very easy question I guess. So A1, so HBr, what will happen? Peroxide rule will be applied, right? So I have CH3, here H will be added, then I have C, Br, H and CH3, right? This is the first product. Second one, what will happen? Woods reaction, right? 1, 2, 3, 4. So if you have 2 times of CH3, CH2, Cl. In presence of sodium ether, it will form Woods reaction and we will get this one. Now third one is what? NaOH at 623 Kelvin and 300 atm, very high pressure and temperature, Cl will be converted to OH. Phenol you will get here. Okay. Next, explain Seidzeff rule. So according to Seidzeff rule, what happens? During dehydrohallucination, more substituted alkenes are formed. Okay. So this one carries 2 marks. So you have to write with an example. So let us write an example for this one. So suppose I have propene. Okay. Not propene, I have butene. Okay. So I have 2-chlorobutane. So I have like CH3, CH2, CHCl, CH3. Okay. 2-chlorobutane in presence of alcoholic KOH. So there is a possibility that I get but1-ene and but2-ene. So more substituted alkene will form. So but2-ene will be the major product here. Okay. So I will get this one as the major product. Okay. So this is the example of Seidzeff rule. So 3 + 2 5 marks, and this is a very easy question. Okay. Next, we'll go to give the chemical equation for the conversion of propane nitriles into corresponding ketones by using phenyl magnesium bromide. Write the IUPAC name of the product. Explain HVZ reaction with an example. Okay. So here if you write the reactions and the IUPAC name, that will give you 3 marks. HVZ reaction with an example will give you 2 marks. Okay. So let us first write the first part. What is there? Chemical equation for the conversion of propyl nitrile. So I have CH3, CH2, C triple bond N. Okay. Propane nitrile into corresponding ketones by using phenyl magnesium bromide. So I have phenyl magnesium bromide. So you can see this is plus minus, this is minus plus. This one will attack here, this bond will shift here. So what will be the product formed here? CH3, CH2, C double bond N. Okay. And here I have added pH and here I have added MgBr. Next, if I do hydrolysis, okay, so what will happen? Here I will get CH3, CH2, C double bond O and pH. Okay. So now what will happen? Here what is the IUPAC name of this one? 1-phenyl. Okay. 1-phenyl. I have propane 1-ONE. Okay. So here you will get 3 marks. And next, what is HVZ reaction with an example? So carboxylic acid containing the alpha hydrogens react with chlorine or bromine in presence of small quantities of red phosphorus to form alpha halo acids, right? And if you want to write one example, you can take this one, X2 red phosphorus H2O, that will replace this alpha hydrogen with the X group. Okay. Yes, now let us go to the next. So we got 2 questions from aldehydes already. Next question, write the reaction involved in the mechanism of acid catalyzed hydration of alcohols to alkene. Explain the preparation of anisole by Williamson ether synthesis. Okay. So this reaction mechanism, very, very important question. You can see here that formation of protonated alcohol is there. So first of all, what happens? Step number 1, alcohols get protonated. Second step, there is formation of carbocation. The water leaves here and you get a carbocation here. The third one is the formation of ethene. So this H plus comes here and we get a ethene molecule, and H plus is released out because H plus is a catalyst used here. Okay. So these are the 3 steps, very important steps. You must remember it. Practice again and again. The next part was what? Explain the preparation of anisole by Williamson ether synthesis. Okay. So if I have anisole, so you can write down B part. You have to first explain, right? So you have to write here phenoxide or sodium phenoxide. Sodium phenoxide. Directly you have to write the reagent, reactant and the product. Okay. Sodium phenoxide reacts with, okay, you can write methyl chloride, okay, to form anisole. Okay. So if I write here, you have sodium phenoxide, okay, plus methyl chloride. That will give you what? This one will react with this one. So you will get OCH3 plus NaCl. Okay, so that will be formed and that is the reaction you have to write. This will give you 2 marks. Okay, so this 3 marks, 3 steps, 3 marks, and this one will give you 2 marks, so total 5 marks. So this is also very easy question and direct question. Now we will move to the section A, numerical questions. That there will be 6 questions, you have to attempt any 3. From each chapter you will get 2 questions. Okay, so the first question is that from your chemical kinetics. Okay, so this is 3 marks. Okay, so these are 3 marks question. Okay, 3 marks. So that in a first order reaction, the time required for completion of 99.9% is 10 times the half life of the reaction. So it is like we have to show that T 99.9% is equal to 10 times of T 50%. Okay, so how to show this? You have to write LHS and RHS. Okay, so according to LHS, what I can do, see, T 99.9 is equal to 2.303 by K log of A naught is 100, 99.9 means this is 1.1, right? So that means I can write 2.303 by K log of 10 to the power of 3, or I can write like 2.303 into 3 by K. So that will give me 6.909 by K. So I can just write it like 6.9 by K. Next we will do RHS side here, right? RHS is what? 10 times of T 50%, right? That is 10 times of 0.693 by K, and that will give me 6.9 by K. So LHS is equal to RHS, so the statement is given correct. Okay, so you have to write, since LHS is equal to RHS, T 99.9% is equal to 10 times of T 50%, hence proved. Okay, next 5% solution. So this first question was very easy. A 5% W by W of cane sugar in water has a freezing point of this much. Calculate the freezing point depression constant given the freezing point of pure water is given to you this much. Okay, we can solve this one. So we have 5% W by W. So what is the concentration? 5% W by W. Okay, next we have freezing point of 271 Kelvin. So TF is 271 Kelvin. Calculate the freezing point depression constant, KF. This has to be KF. Okay. Given freezing point of pure water, you have T naught F is 273.15 Kelvin. Okay, so now what we have to do? We have this formula. So let us first understand what is this 5% W by W means. This means that we have solute. Okay, solute is 5 gram. 1 second. Yes, so solute we have is 5 gram. What is the solute? That is your cane sugar. Okay, cane sugar we have 5 gram. Then it is given in water, that means solvent, or I can say water is 95 gram. Total mass of the solution is 100 gram, whereas 5 gram is solute and 95 gram is solvent. Okay, so I have got all the data that is required. So I have delta TF is equal to T naught F minus TF is equal to KF into M. For molality, W2 by M2 into 1000 by W1. So here I can mention what is W2. W2 is the mass of the solute, right? W1 is mass of solvent. Okay, next I have M2 is equal to molar mass of solute. Molar mass of solute, right? This is done. Now let us substitute. What is T naught value? 273.15. TF value is 271 is equal to KF into W2 is 5 gram, 342 gram into 1000 by 95. So you have to solve this, put it in the calculator and find the value of KF. You will be getting around 13.97. Okay, please check the calculation and let me know if you are getting this answer or not. Okay. Next, we'll move to question number 43. The molar conductivity of 0.025 mole liter inverse methanoic acid is 46.1 s centimeter square mole inverse. Calculate its degree of dissociation given lambda limiting molar conductivity of H plus and HCOO minus. Okay, so we have the first value that is given to us is molar conductivity is how much? 46.1 s centimeter square mole inverse, right? Okay, next I want to calculate limiting molar conductivity. Okay, limiting molar conductivity will be the conductivity of H plus, and for the this one will be for HCOO minus. Okay, so that is equal to 349.6. okay, and then we have 54.6. okay, so here it will be 6 plus 6 12. I'll add here 1, 9 plus 1 10 plus 4 14. I'll add 1 here, 5 plus 4 9 plus 1 10, 1 here 404 s centimeter square mole inverse. Okay, so this is I got lambda naught m. Now what is the value of alpha? Alpha is equal to lambda m by lambda naught m. So that is equal to 46.1, right? Sorry, I forgot to put here 46.1 by 40.2. Okay, so I have to just calculate the degree of dissociation, right? It's not dissociation constant. So if I solve this, you will be getting around 0.114. Okay, so please check this calculation and let me know whether you are getting or not. So alpha will have no unit, so it is 0.114. Next, we'll go to question number 44. Henry's law constant for the molality of methane in benzene at 298 Kelvin is given to you this much. Okay, so Henry's law constant is given to me 4.27 into 10 to the power of 5 mmHg. Okay, calculate the mole fraction of methane in benzene at 298 Kelvin under a pressure of 760 mm of Hg. This is very simple and direct question right from Henry's law. We have P of the gas is equal to Kh into mole fraction of the gas, right? So I have to calculate pressure of the gas is given to me 760 and Kh value is 4.27 into 10 to the power of 5 into mole fraction. What is the value of mole fraction? 760 by 4.27 into 10 to the power of 5. So if I calculate this one, you will get around 1.78 into 10 to the power of minus 5, or you can write it like this. Okay, so this will be the value of the mole fraction. Okay, this is also very easy question. Next, two electrolytic cell A and B containing solutions AgNO3 and copper sulfate respectively are connected in series. A steady current of 1.5 ampere. Okay, so we have two solutions A and B. In A we have AgNO3, okay, and in B you have copper sulfate. Okay, fine. Current is given to you how much? 1.5 amperes. Okay, is passed through a solution until 1.45 gram of silver is deposited. So mass of silver is 1.45 grams. Okay, how long did the current flow? You have to calculate time for which the current flow. Okay, and what mass of copper was deposited? Mass of copper that was deposited we have to calculate. Atomic masses are given to you. Okay, so we have this formula first, Faraday's first law, m is equal to z into I into t, right? What is the mass of silver deposited? We have 1.45 gram. Z is equal to what? Molar mass of silver divided by 96500 into n. For silver, n is 1. Current I have to 1.5 ampere, and then time has to be in seconds. So you have to solve this and calculate the value of time. Okay, that is the first part. Next we'll go to the second part where we have to use Faraday's second law. So mass of copper deposited by mass of silver deposited is equal to equivalent weight of copper by equivalent weight of silver. Okay, so now if I substitute the values here, mass of copper deposited I have to calculate, mass of silver deposited is 1.45, right? Equivalent weight of copper will be 63.5 by 2. Why? Because copper 2 plus requires 2 electrons to get reduced. Equivalent weight of silver will be 108 by 1. Okay, so you have to calculate this and then you will get the value of mass of copper. So the values that you will be getting here for time will be somewhere around 863.7 some seconds, or roughly I can say 864 seconds. Okay, and here mass of copper will be 0.43 gram, roughly equal to 0.43 grams. Okay, clear? Next we'll go to last question. The rate constant of a reaction is given by log K is equal to 13.25 minus 1.28 into 10 to the power of 3 K divided by T. Calculate the activation energy and the pre-exponential factor. Okay, so you have this equation, K is equal to A into e to the power of minus EA by RT. Now if I write it in terms of log, I'll get log K is equal to log A minus EA by 2.303 R, okay, into 1 by T. Now what happens here? This will give me, if I compare it with this one, 13.25 minus 1.28 into 10 to the power of 3 divided by 2.3, sorry, one second, yes, this is not there, right? So this, according to the equation given, this is the equation given. Now if I compare this one with this one, so I can say that log A will be equal to 13.25. Fine. So what I can say, A will be equal to 10 to the power of 13.25, okay, or I can write 10 to the power of 13 into 10 to the power of 0.25. Okay, next coming to this part, so I can write that EA by 2.303 R will be equal to 1.28 into 10 to the power of 3. What is the value of EA? That is equal to 1.28 into 10 to the power of 3 into 2.303 into R is 8.314. Okay, now you have to solve both of this, and the answer you will be getting here is, for activation energy it is 24500, and here, so you can write down the units also. So joules here, and here we will get activation energy A formula, that is 1.77 into 10 to the power of 13. Okay, so this will be the answer. I think we have given all the answers here. So let me just check once. Here I have written seconds and this is gram. Okay, please mention the units if I have forgotten in any question. Let us see. Here, what is the question? You have to find the mole fraction. Mole fraction has no unit, so this is the answer here. Next 43, you have to find alpha, it also has no units. Next coming to 42, you have to find the value of Kb, right? So yes, so this answer will have Kelvin, kilogram per mole unit. Okay. Next we have proof. So yes, that also has no units. Okay. So one second. Yes. So we have solved all the questions. Okay, so students, now you have to practice these questions. If you have any doubt in any question, please do comment down, and we will also be solving the model paper 2 as well, so that you do not have any confusion in any question. Okay, so let's get boost of our preparation. Let's be very serious about our studies for the next few months, because we are in the phase of exam. So students, all the very best. Please keep your preparation level very high at this point of time. This can be your make or break period. Okay, so all the very best and thank you, and please do not forget to subscribe the channel, and see you soon in the next class.